This is my tutorial for a 13-inch long dado router jig. Here are my boards ready to cut to create the jig. These came from cutoffs I had lying around. As we zoom into the print, you can see the dimensions of the 4 pieces I need to cut. The 1 3/8 is critical, as that is the outside diameter of the router guide bushing. The 4 5/16 dimension is my calculation that will put the center of the dado at 5 inches from the edge of either board. Now off to the table saw. Since these were from cutoffs, I'll first rip one edge so that I know it is square and straight. Then I will reset the fence to rip both boards at 4 5/16 inch. The 2 boards are not the same length, but I will take care of that after the glue up. Now cutting the spacers, but I will first rip for the non-critical dimension of 1 1/2 inch. Then I will get out the crosscut jig. I will use a scrap board to set the stop on the crosscut jig for about 1 3/8. First I trim the edge to make sure it is square, then mark the cut and grabbed another board and clamp to use for the stop. I made an error with this first cut since I cut on the wrong side of the blade and it was 1/8 inch too short. I marked the blue tape and then tapped the stop over about 1/8 inch and made more cuts until I was satisfied it was in the correct location. Since this is critical, using my calipers to ensure I'm at the right length, and then once I am happy, I cut the 2 pieces and mark them number 1. Now tapping over the stop, and I cut another set just a bit longer, marking them number 2, and then one more time marking them number 3. This is in case my first set is just a little bit too small. Using a couple of bar clamps to hold it together to check the fit of the router bushing. If the spacing is correct, the bushing should drop in with only slight resistance all the way from one end to the other. Looks like I had the first set of spacers cut just right. I want to make sure the jig is flat when glued together, so I will be doing it directly on top of my workbench. So first, I run the belt sander lightly across the area to clean it up a little. Just butt gluing these together would result in a very weak joint, so I basically have 2 choices. I could use a biscuit, but it would be very hazardous to attempt to cut a biscuit slot into the small spacer, or the other choice would be dowel pins. There will be 4 pins in each spacer. Here I am labeling the boards and spacers so that they are ensured to go back into the same place after the holes for the dowel pins are drilled. I simply labeled them A and B. I estimate about where I want the dowels and then mark a line across the 3 pieces. I do the same thing on the other end, but after clamping to keep the boards aligned. Here is the dowel jig I will be using to drill the 1/4 inch holes for the dowels. When I marked the lines for the dowels, I did not realize they were almost exactly the same spacing that was on the jig, so I installed the other 1/4 inch guide in the jig. Now on the carpenter's bench, getting set up to drill the holes. On the bottom side of the jig, there are lines etched centered on the guides, and those are used to line up the lines marked on the board. Placing the jig on the board and then just line up the lines and clamp it in place. Now I install a drill stop so that it is 1/2 the length of the dowel. I draw a line at the midpoint of the dowel and then set the stop just above the line, ensuring that the hole is just barely over 1/2 the length. There is a burr on this drill, so it's a little tight at this end, so I have to tap it a bit with a hammer. Now that I'm set up, you would think we are now ready to drill, but first, I must test this setup on a piece of scrap to avoid an error. I drill a hole in 2 scrap boards, tap in a dowel, and check to see that they are lined up properly as well as the depth of the hole, and when satisfied all is good, start drilling the project boards. Due to poor lighting, I grab a flashlight to ensure the lines on the jig are lined up with the lines on the board, then repeat for the other board. Now I have the 2 spacers and perform the same procedure on each end of both spacers. All parts back on the bench, and now for the first test fit. Install the dowels, assemble, and clamp, then check with the router bushing. It was a little loose, but I found it was because the clamp was also loose, and now we are ready to glue it up. Most any glue would do, but I am using polyurethane only because I'm getting to the end of the bottle, and this bottle is a bit old, so I needed to use it up. Since I will be gluing directly to the top of the table, I will lay some boxing tape to prevent gluing it to the table. Spraying with water because this glue cures with moisture. A small drop in each hole, then I tap the dowels into the spacers and apply glue where the spacers will meet the bases. Insert the spacer assemblies into one base, then the other base on top. Lay on the table and clamp together, ensuring that they are flat on the table over the tape. To keep it flat on the table, I place a bucket of rocks on top of it. Now the glue is set and bucket of rocks is gone, and we're going to see how easily this pops up off the bench. After removing the clamps, you see it comes right up. I am a big fan of using boxing tape as a glue barrier. Now to move to the other side of my shop on the carpenter's bench where I have a larger clamp. Using this clamp because it clamps at the spacer width and will not collapse the center. The glue is not fully cured, so I remove the squeeze out with a chisel so it doesn't gum up the sandpaper. Now run the belt sander top and bottom so that everything is flat, then check to ensure a proper fit for the router bushing. Back on the table saw with a crosscut sled to trim the ends. This dimension is not critical, so no measurement is needed. Last thing to do is put it on the bench sander to put a radius in all 4 corners, and it will be ready to test. Now that I have my new jig, it is time to document how to use it. And then there's the issue of us crazy Americans and not fully converting over to metric. I created the jig with a 5-inch center to edge spacing, but the router bit is 18 millimeters, so we're going to have to do some math to find out where to set the jig. 5 inches equals 5 times 25.4 equals 127 millimeters to the center of the slot. To set the jig for a rabbet from the edge of the board, center to slot plus 0.5 times dado equals 127 plus 0.5 times 18 equals 136 millimeters, or 136 divided by 25.4 equals 5.3543 inches. 0.3543 times 32 equals 11.338, so 5 and 11/32 inches. Don't you think the American measurement system is fun? For dados, I would prefer to measure to the center of each dado instead of the edge to avoid the error of selecting the wrong edge. So, to set the jig when measuring from the center of the dado. Center to slot plus jig edge to center equals 862.3 plus 127 equals 989.29 millimeters, or 989.29 divided by 25.4 equals 38.94831 inches. 0.94831 times 32 equals 30.34583, so 38 and 30.330 seconds, or 0.94831 times 16 equals 15.17291, or 38 and 15.216. I think I'm going to prefer to use metric measurements. What do you think? Time to test the jig. I have one line drawn for the rabbit as a reference, and now I need to mark a line for the jig at 136 millimeters from the edge as indicated in the previous calculations. Using a combination square on the mark at 136 millimeters, I place the jig against the square and, while firmly holding it down, clamp it in place. The router depth has already been set, but since this is the first test cut, I am performing a visual inspection to see if it is even close to where it should be cutting. The first test cut is complete, but is it right? I clean up the edge and test fit with a board. The first cut was off almost 1 millimeter, and I found it was due to the scrap board edge not being square, so I squared up the board and then made 2 more cuts, and it was perfect. You can check out the small bookcase project that this was made for to see it in actual production use.